Hi students, once again I welcome you all to my channel, Abrar sir classes. ಇವತ್ತು ನಾವು EMI Chapter ನ Mutual Induction topic ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡೋಣಪ್ಪ. First we learn what is meant by Mutual Induction. Whenever the term Mutual Induction comes, you have to think of two coils kept side by side. The production of induced EMF in a coil due to the changes of current in a neighbouring coil is called mutual induction. How many coils are there here in this figure? There are two coils. This is called what? Primary coil. Okay, this is called primary coil and this is called what? Secondary coil. Always source is connected to the primary coil. Okay, battery is connected to the primary coil. Nodappa, okay, when key is pressed, IP is increasing. If IP is increasing, what happens here? There will be a development of magnetic field. Okay, how the development of magnetic field will be like this. Okay, like this. Okay, that is BP. This is magnetic field developed in primary coil. Okay, and which is increasing. Why? Because IP is increasing. So this is in the clockwise direction. Idu south pole appa, idu north pole agutte. Therefore, in the secondary coil, since IP is increasing and BP is increasing, now here you will get a magnetic field in the opposite sense. It will try to repel it opposite. Okay, now here BS will be like this. BS it will adaga. So this will become what? North pole. This will become south pole. In case of north pole, we know how the direction of current will be. How the direction of current will be. In case of north pole, it will be anti-clockwise direction. Okay, this is what in the clockwise direction. So here it is in the anti-clockwise direction. Okay, in the second coil. Understood? If IP is increasing, okay, you will get a induced current in the second coil in the opposite sense. Okay, if this is clockwise, this will be anti-clockwise. Now here slowly the key is released. Okay, key is what? Opened. Okay, it is closed. Okay, key is closed and key is what? Opened. Once its key is opened, current starts decreasing. But this is in the clockwise only. This is in the clockwise only. And what happens to the magnetic field? Magnetic field in primary coil decreases. Therefore, here you will get a magnetic field in the secondary coil of the same sense, the same BS. Okay, ಇದು ಸೌತ್ ಪೋಲ್, ಇದು ನಾರ್ತ್ ಪೋಲ್, ಮತ್ತೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? ನಾರ್ತ್ ಪೋಲ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಸೌತ್ ಪೋಲ್ ಇರುತ್ತೆ. ಓಕೆ, ವಿ ನೋ ಇನ್ ಕೇಸ್ ಆಫ್ ಸೌತ್ ಪೋಲ್ ಇದು ಏನಪ್ಪ? ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್. ದಿಸ್ ವಿಲ್ ಬಿ ವಾಟ್? ಇನ್ ದ ಸೇಮ್ ಸೆನ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೇಮ್ ಸೆನ್ಸ್ ಕ್ಲಾಕ್ವೈಸ್, ಬಿಕಾಸ್ IP is decreasing and in the clockwise direction. Hope you understood. When key is pressed, okay, you will get a induced EMF, okay, of induced current and induced EMF of the opposite sense. IQ is what? In the opposite sense of IP. If it is increasing, IQ will be in the same sense, okay, when IP is decreasing. Hope you understood this. Keeping this in view, we will solve the problems. Hope you understood. Whenever the term mutual induction comes, we have to think of two coils. Always battery is connected to the primary coil. Okay, and in the secondary coil we can connect galvanometer. Show the deflection. Okay, it is coming to the left side and it is coming to the right side here. Okay, and here the direction of current will be in the opposite sense of what is there in the primary. If it is okay, if the field in the primary is increasing or current in the primary is increasing, if the current in the primary is decreasing, similarly field also decreases, and here in the secondary coil, okay, you will get a current of the same sense how it was there in case of what? Primary coil. Now keeping this in view, we will try to solve the problems. Okay, now first problem, as shown in the figure, P and Q are two coaxial conducting loops separated by some distance. Okay, P and Q are. When the switch S is closed, oh, S is closed up. S is closed. When S is okay, S is closed. S closed ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? Okay, there will be a current. There will be a switch is clockwise current, okay, clockwise current is flowing like this, IP, and which is increasing also. Why? Because switch is closed. Yes, okay, yes is closed. ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? IP increases. Since IP increases, what happens here in the other coil? There will be development of current in the opposite sense, and he's saying it is IQ1, and induced current IQ1 will be flowing in the opposite sense. IQ1 will be an out there. IQ1 will be, this is what? This is clockwise. Okay. IQ1 will be in the anti-clockwise direction. Okay. And switch is closed. Hope you understood. IQ1 anti-clockwise. Now, the second case when S is opened. Okay. S is what? Opened. S is open. Switch is open. What happens to IP? IP what? Decreases. IP decreases. But it will be clockwise only. Okay. What happens to IQ2? Okay. It will try to support that one. Okay. So you will be getting a current in the clockwise direction. IQ2 nagutte, IQ2 idhar clockwise direction. IQ2 is the clockwise direction. Hope you understood. When S is closed, okay, you will get IQ1 in the anti-clockwise direction. When S is open, you will get IQ2 in the clockwise direction. Respectively, clockwise, anti-clockwise. No, first one is anti-clockwise, second one is clockwise, right? Both clockwise, wrong, both anti-clockwise, respectively anti-clockwise. This is right. So hope you understood this. Very easy sum. We'll go to the next sum. What it is saying, figure shows two coils placed close to each other. When the current through one coil is increased gradually, shifting the position of the rheostat. Okay, they have given the direction of current. Direction of current ಏನದಪ್ಪ? Clockwise ಇದೆ. Okay, clockwise ಇದೆ. Okay, and it is increasing also. It is what? In the clockwise direction. Clockwise ಇದೆ. ಈ ತರ. Okay, you are observing from here. Now here, what will happen? Here the current will be in the opposite direction. It will be in the anti-clockwise direction. I will be what here? Anti-clockwise direction. Anti-clockwise direction andre it will be like this. It will be okay from A, B, and C. Understood? A, B, and C. See, this is clockwise. Idu enagutte anti-clockwise. Okay, anti-clockwise. A, B, C. A current flows along A, B, C. Right. A current flows along C, B, A. No, wrong. This is wrong. No current flows. Okay. Alternating current flows in the other coil. Okay. A current flows in what? Along A, B, C. The right answer. Hope you understood this one. Same concept. Okay. Now let us see this one. Three identical circular coils A, B, C are placed coaxially with their planes parallel to each other. Okay. The coils A and C carry equal currents. Into clockwise nalide. Okay, idu anti-clockwise direction, right? Okay, equal currents. Okay, in the opposite direction. The coils B and C are fixed. Okay, it is B. B is fixed and C is also fixed. There is no relative motion. Okay, both are fixed. These two are fixed. Okay, so no induced current. No induced current in B. Due to what? Due to C. Because there is no relative motion between B and C. Okay. No flux is getting changed. Therefore, no induced current in B due to C. No. The coils A and C carry equal currents in opposite location. The coils B and C are fixed in position, and the coil A is moved towards B. This coil is moved towards B and okay. With a uniform motion, what happens? Okay, the current is what? In the clockwise. Here you will get a current in the opposite sense, anti-clockwise direction. Current flow out. So easy it is. Okay, there is no induced current in B. No, this is wrong. Current produced by A and C in B will be equal and up. This is wrong. Okay, there is an induced current in B which is in anti-clockwise direction. Right, this is the right answer. Okay, there is induced current in B which is clockwise direction. No, this is wrong. Okay, it is opposition. This is clockwise, it is anti-clockwise. So easy it is. We'll see the next sum. Electron moves. Okay, slowly the electron is moving up. Okay, only one electron is moving like this. Okay, Now, what happens to the differential current? A small current, let us say differential current di. Okay, di is flowing like this, opposite to what? Opposite to the movement of what? Electron, di. What happens? It lies in the same plane as a circular loop of conducting wire as shown. What will be the direction of current induced, if any, in loop? Now, slowly, what is happening? If the, okay, this is di, this is what? Electron, this is electron is moving, and this is what? Current in the opposite. If the electron is moving, slowly the field is what? Increasing. Okay, field is increasing. See, current is flowing like this. How the direction of magnetic field will be? Magnetic field will be what? Inside it. Inside it. Right. Because current is flowing in the clockwise direction. Right? This one. Okay. You know. Okay. North pole. Anti-clockwise direction. How it is shown? Like this. South pole andre that I have shown you in the previous videos also. This is what? Outside. Okay, this is what? Clockwise. Okay. Just okay. Clockwise. This is clockwise. Clockwise direction. Now, since the field is what? This field is increasing. This field is increasing. Therefore, this loop will produce a magnetic field of opposite sense. This is B is developed here. The anti-clockwise direction. Current will be what? Anti-clockwise direction. This current will be in the anti-clockwise direction. Understood? Now slowly, when electron, I will be anti-clockwise direction when the electron approaches. When the electron approaches. This is very, very important. Now, when electron recedes, when the electron recedes, ದೂರ ಹೋದಾಗ ಏನಾಗುತ್ತೆ? Field what? Field decreases. Field ಏನಾಗುತ್ತಪ್ಪ? ಇದು field decrease ಆಗುತ್ತೆ. Since field is decreasing, it will produce a what? The loop will produce a same field in the same sense. Okay, it will be cross only. If it is cross, you know it will be clockwise direction. I will be clockwise. I will be clockwise. Okay, I will be in the clockwise direction when electron recedes. Now here the what it is saying? What will be the direction of current induced? No current will, no, this is wrong. The current will be in the clockwise. No, both in the clockwise as well as the anti-clockwise. Okay, the current will change direction as the electron passes by. Right. This is the right answer. Okay, when the electron passes by, the current will change. Okay, its direction. Understood? In the conducting loop, circular loop. Hope you understood this. If you have liked this video, kindly like it, share the video with your friends, ask doubts in the comment box, okay, and subscribe for my channel. Thank you one and all.